Be good. All right, so decimals. Are fractions, right? We talked about that before. And we started using our base 10 blocks last time. And if we just change the key, instead of calling them ones, tens, and hundreds, we could let this big guy be ones. And what would the long, skinny guy be? Almost tenths, right? It'd be tenths, because it's 10 of them to make that. Yeah, so this would be our tenths with a TH. And then the little yellow guy, how many of those do I need to make a 1? I need 100, so there would be hundredths. So this guy right here is our hundredths with a TH. Yep, hundredths. So we can still use these as a model to play around with fraction addition, subtraction, multiplication, and division. So let's take a look at addition. With these things, we could easily represent something like 1 and how about 12 hundredths? The proper way to read it compared to our slang 1.12. And so as teachers, we're going to revert to that because we say it all the time in our lives. We want to pause whenever we're dealing with decimals with kids and read that properly. Because then we just get that better number sense with kids. And we can show what that looks like, right? So take the toys in front of you and let's make a quick picture of 1 and 12 hundredths. So I would want to grab one of these guys and I would want one of those guys and 2 of these guys. Okay. And then we could also demonstrate another number, like let's demonstrate, how about 2 and 35 hundredths. Okay, you may or may not have enough to demonstrate that. I'm going to run out of room quickly on my screen here. Oops. All right, so I'm going to have to stack them a little bit to make that happen. There's my 2. Here's my... Now, could I call these 3 green things, could I call them 30 hundredths? Would that work? Because don't I have 35 hundredths here? So wouldn't the green part be 30 of the 35? Right, yeah, so I could, so decimals, like other fractions, do have different names. Like 1/2 is also 2/4 or 3/6. Same thing applies to decimals. We could call this green stuff 3/10, right? Or like it's written up there, we could say it's 30 100ths, depending on how you view it. Some kids will look at this and they see all those divisions, right? Aren't there 10 little squares living in there? Yeah. So there are different ways we can view those, and these toys help us feel that value that's living in there. All right, so we can easily represent decimal values by just changing the key that we used to use with these base 10 blocks. We can take it a step farther by saying, hey, can we use those toys to then do something like addition? So what does addition mean? Put together or combine, and what's the catch at the end? Count. Yeah, you got to count them up too, okay? So combine and count. So just a little note down here, add means combine and count. Oops, count. There we go. Means combine and count. Well, that's a little easier than fractions because the whole point of decimals was to fix the denominator with respect to 10. Forget about halves, forget about thirds, forget about fifths. Let's just work with 10. And so we can easily look at this and say, well, you know, I've got 1 Oops, different color. Let's use highlighter maybe. I've got 1, 2, 3 holes. And I've got 1, 2, 3, 4 tenths. And then I have 1, 2, 3, 4, 5, 6, what, 7 hundredths? So pretty quickly, someone can look at this and say, oh yeah, this is pretty straightforward. I have 3 and 47 hundredths. Is that what we got here? Because all the pieces are automatically the same kind of pieces. So decimals are much easier to add than fractions are. And the bigger the numbers, the more problematic these toys are. These toys are just to get number sense to get started. Then we develop an algorithm. Okay. Well, algorithm relates to my model here. This 1 right here and that 2 right there, those are my big critters on the screen. And the decimal basically separates the big critters from the little critters. So in terms of adding decimals, what matters is the decimal point. 1 and 12 hundredths added to 2 and 35 hundredths. The important part here is to line up the decimal. Now with the kids, you'll do more than one example of playing with the toys. You'll do it over and over again, and eventually the kids will see it before you would have to say it. Oh, lining up the decimals is just like lining up the toys. And they'll come up with their 3 and 47 hundredths. Okay. Now with this example, that looks pretty straightforward, but I'd like you to build a different example and then we'll compare it to the algorithm. So consider instead, suppose we had 1 and 2 tenths, and we want to add that to 1 and how about 30, let's go with 7 hundredths. So model those first, and then we'll consider the algorithm.
Like you want us to draw pictures, or?
Either draw a picture or whip out the toys. I'm going to use my digital toys here to do so. Let's see back here. I need all of these guys. Okay, so let's see. I have my 1 and 2 tenths, and here I have my 1 and 37 hundredths. Okay, I think I drew that right. Do your pictures or toys match mine? And then if we want to add them, that just means put them together and count, and counting's pretty straightforward. How many 1s do we have here? We have 2 of them, right? Thinking back to our key, so in a classroom, you'll probably want to have off to a side a key that the kids can keep referring back to so they don't get confused. Our key is back here. 1s, tenths, and hundredths is that little one, right? So that's our key from the previous problem. And depending on what you're doing, you might do a different key than that. So that's, these are my, I'm writing on the board right now. Those of you on the internet, sorry. 1s, tenths, 100. So that's the current key. All right. So off from that current key here, and then how many tenths do I have? Well, I count 1, 2, 3, 4, 5 of them. And then I count 7 hundredths. Counting them is like expanded form. Remember expanded form before? I have 2 1s, and I have 5 tenths, and I have 7 hundredths. Remember, expanded form still applies. Now, what kinds of errors are kids going to make here? Well, kids, based on what they did with whole numbers, might do something and write it like this. Because with whole numbers, they were just used to lining up on the right side. But before decimals, what was always on the right side? What place value? The ones. So we could make a note, say, no, think back to this problem right here. When we added whole numbers, we really lined up the ones, right? So we can change their perspective by bringing them that, try and connect it to something that they're familiar with. So then we can say, oh yeah, that's not going to work here. If I line up the ones, that coincidentally lines up the decimal point. Oops, I missed a digit. And my tools. And then it matches the model that we had. So the model can help avoid mistakes like that. Okay, once we get started, other things to consider. Consider, let's see, how about, yeah, these guys right here. What is the name of what I've circled right there? Well, how do you call that? What is it? It's 2/10 is one way to call it, which would be written like, oops, like this, right? Is there another name you can give that 2/10? 20 hundredths, right? It's 2/10 or 20 hundredths. So sometimes when we first start out working with decimals, ooh, why did I put a 5 there? Because my brain trying to write a 2. Oops, that's not an eraser. And here, 2, 2. If we think about that and fill in zeros of missing ones, which generally is what happens in the early curriculum, then we don't have that problem as much. But eventually they are going to see things without the 0 as a placeholder, as a filler. And we still got to get it right. Is subtraction algorithmically much different than addition? The answer is no. Lining up the place value is the key thing there. We then just have to decide, what is our model, comparison or takeaway? So let's just do an example of that before we move on. So I'm going to look at subtraction as comparison. So that means if somebody gives me a problem like 1, and we'll just do something simple like 5/10, and we want to subtract from that, let's say 3/10. First, build that as a comparison, which means you have to show both 1 and 5/10 and 3/10 at the same time if it's a comparison. And let me grab my toys. There you are. All right, so I got my 1 and 5/10 above, I have my 3/10 below, and we want to line up where do they match and where they don't is the comparison model. And so these two match up, and these two match up, and these two match up. How are they different? I'm using the comparison model, not the takeaway model. So that's the key. I have to state up front, what does subtraction mean? Right? So comparison's a little different than takeaway. Same answer, just a different approach to looking at it. And I'll show you another example as to why I prefer comparison here than takeaway, but let's start off with this easy one. So comparison model basically says, how are they different? Other language we might use with the comparison model is what is the difference? And in math, when we're trying to compare two things, we have two different ways to do so. One is subtraction, the other is division. We can compare by matching them up, or we can compare by a ratio. And so what I see here is, although those match up, they don't match up given one of the wholes and then 2 of the tenths. So the difference is 1 and 2/10 from the comparison. And the key here, which we can show later, is if we write down 1.5 and stack under it the 0.3, as long as the decimal is lined up, we can kind of ignore it and say 5 things minus 3 things is 2 things. Those things happen to be tenths. Oh, 1. Yep, sorry. 1 minus 0 is 1. Good call. Another thing, notice I don't know if maybe you have noticed, or maybe you haven't. I usually put a 0 when there's no ones. I highly recommend doing that because most kids are kind of messy because they're still figuring stuff out. And a lot of times they might write something on paper, or they don't see clearly what you wrote somewhere on a board. And if you just write that, some kids might not see the little tiny point if you made it small. But if you put a 0 in front, we would never write 0, 3 for the number 3. So then the kid might go, oh, the teacher means 3/10. Okay, I get it now. So I'd highly recommend putting the leading 0 when you first start off working with decimals, just to be clear with the kids about what you're doing. All right, let's try another example. Let's try, here's my toys. Let's move them down a touch. Blue is fine. How about 1 and 21 hundredths? Take away, how about 7, or let's go 16 hundredths. Oops, missing a 1 there. 16 hundredths. So I want to do comparison, which means I need to show both numbers. That is a lovely fort you got there. So I'm gonna show downside of having toys in class. Sometimes they get put to alternative purposes. So here's my.
I always do that.
What did you do?
Taking them away, right?
And we're comparing. We're doing comparison again. Oh, you're doing takeaway? What's going on? What do you always do?
Always like for the tenth, I always add only 1 and forget to like I just add the 1 less than I need. If that makes sense.
I think I got to see that one. Oops. One, 2, 3, 4, 5, 6. Okay. So let's see, 1 and 21 hundredths and then 16 hundredths. Okay, so I think I have my sets drawn there. So then we want to start matching them up. And these two match up, right? And then let's say these two match up, but now I've got a slight problem in my comparison because I don't have enough above to compare. Yeah, so we're going to have to break these guys up. So I need to do a trade-in. So I'm just going to make a note on my paper, and the kids are just going to do this physically. I want to trade 110 for 10 ones. Oops, no, I lied. I'm using the wrong number system. I want to trade 1/10. Where's my color? There we go. For 10 hundredths. Hundredths. Okay. So basically, I'm just going to cross that guy out there, and then I'm going to introduce 10 hundredths. You guys have the toys, which is way easier than this digital model. So technology isn't all it's cracked up to be, because with the certain tools, it's harder. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I did it. So now I can continue my comparison once I've done that trade-in. So I was using blue to compare. So my comparison continues, matching things up. And now I want to consider all the stuff that's not matched up. So let's see. I have a 1 that's not matched up, right? All my tenths are gone, is that true? Yep, they're either matched or traded in. And so then I just have some of these ones over here, or hundreds, excuse me. 1, 2, 3, 4, 5, 6 of them? Yeah. Okay. Seven over here. 1, 2, 3, 4, 5, 6, 7. Okay. So it looks like the result is 1, no tenths, and 7 hundredths. So now we can double check with some other method. Did you miss this one over here?
Yeah, I got 5.
Oh, where do I have a mistake here? Somewhere.
Because I think you added way too many. You 1, 2, 3, 4, 5, 6. You should have. Go up there, Maria.
Oh gosh, I forgot to trade. This guy's got to get matched with something. I did it backwards. Yeah. Hang on, let me get rid of some stuff here. Yeah. No, the problem is I forgot to match this guy with something. This guy needs a companion. Yeah, no. Okay, so that guy right there gets matching. Okay, so what didn't match now? I've got that 1 whole, no tenths, and 5 hundredths. That didn't match. And it's way easier with the physical things in front of you because you can just stack them on top of each other. Think again about the addition. We had to take something like 1.21 and subtract 0.16. With addition, once we lined up the place value, we could then kind of ignore the decimal. So let's see what happens as we do that. Change colors. Can I take 6 from 1? Okay, so what am I going to do? I'm going to borrow, which is really trading in. I'm trading one of those tenths, which leaves one behind, for 10 hundredths. And if we look at my picture over here, I traded, so now I have 11 hundredths in the upper number. And here's my 11 hundredths. So the trading in is what allows us to borrow. 11 minus 6 gives us our 5. 1 minus 1 is our 0. And 1 minus 0 is our 1. So that's the comparison model. Now we're going to take a look at, before we go to multiplication, I just want to note something. Take a handful of those little tiny things, the little tiny squares, and a small handful so that you probably have less than 10. Don't count them, but just guess, less than 10. And then drop them on the table in front of you so you can see exactly what set you picked. So I'm going to do something similar on the screen here.
I got 8, 9. I got 9.
You're out of, you've used them all. Okay, so if some things are scattered like this, most of us, like if I just flash that on and off the screen, most of us are like, oh, how many were there? 1, 2, you got to count them, right? Okay, so when you're working with these things, what I've discovered is if you organize them, it's easier to see how many there are. So consider that messy group versus a neater group like this. Well, now suppose I add more here. Can you just look at that real quick and know how many there are? Or do you have to count them? Okay. So I'm going to pull some out. Is this organization easier to look at and count than the previous string all in a row? Clicky. Oh, make it go and come. Still have to count? Okay. So most people, if you do a test, like if you flash groups of blocks on the board, if they're randomly organized, everybody has a hard time with it. But if they're put in grids, people group better, right? Some people look at this and they'll see 2, 2, and then 3 by themselves. Other people see 5 and 2, but they see some kind of pattern there. If you put them all in a row, that's better than scattered, but it's still, if it goes beyond 5, most people have to count. And so what you'd find is if you had a room full of people and you splashed a bunch of dots, most people can recognize a group of 5 no matter how they're organized pretty quickly. Once you get beyond that, then it starts getting scattered. So my point is, when you're playing with these toys and demonstrating with kids, don't make a group of any bigger than 5 at a time, whether it's in a row or a column. Otherwise, it gets too hard to count, and then kids get miscount, they lose stuff. Because a lot of kids, especially, you're gonna have a lot of kids that don't realize they have vision problems yet. And so they're squinting. And it happens to everybody. Like with both my daughters, they were having trouble in school and none of us caught it was a vision problem, not a learning problem. And it happened with both kids, and both my wife and I felt like idiots about it 2 times in a row. Because otherwise they're pointing and squinting and trying to count from a distance, and yeah. Okay, that's a good solution there. Yeah. So it so there's a couple of reasons small groups are nice. One, even if you have good vision, small groups are easy to recognize. And then grouping by 5 is slightly easier than grouping by 10, even though our number system groups on 10. We can way easier understand 2 groups of 5 than multiple groups of 10. Okay, let's take a look at multiplication. We're going to have to change the key to do multiplication. So the new key is going to, whoa, I accidentally resized that. All right, there we go. The new key is going to look like this. Actually, I think I'm going to leave the key the same, sort of. Let me explain. Let's say I need one more toy for this. I need that one. All right, what's our standard definition of multiplication? Repeated addition, groups of, what's my favorite? Anybody remember? My favorite is the area model.
Oh, like that? Yeah, I don't mind it. It just takes forever.
Yeah. Yeah. So we're going to take a look at the area model for multiplication here. Probably. I have a little bit. Let's see, who wants graph paper? Hey. Oh yeah, I got class right now. I'll be free in half an hour maybe. Okay, you want centimeter or little, some of that there? Okay. Does anybody else need graph paper? Okay, let me go get some more then.
Oh, he's going. Anyways. You. I'm going to work. I have to go to work. The day with the immigrants. Yeah, the day with the
Okay, so
we can tell them that's why we need this program.
All right, so check this out. If I let this green and red region be a 1 by 1 region, and I'm considering multiplication as an area, and area, I like to consider a base times height instead of length times width. So if I have a region that has a base of 1 and a height of 1, then the area must be what? 1. Okay. So this is my new key for multiplication. And I'm mainly concerned about the fact that multiplication is an area. So this red shape right here is 1 for an area in multiplication. We did something similar with fractions before.
Could I put my little my pen thing on the other side?
You can put it anywhere you want, yeah. So you could put it on the other side like this. Is that what you mean over there? Yeah. And you could put this one down here. Usually I put them on the top and on the left. So ignoring my little yellow guy down here, pull that out of the way. What I have here is a 1 times 1. No big whoop. However, this does kind of get interesting. I could say this is 1 and 0/10 times 1 and 0/10. And ignoring the decimal point for a second, doesn't that look kind of like 10 times 10? Yeah. And so couldn't I say my whole area is actually 1 and no hundredths? Or one technique I gave before for reading decimals was to identify the place value. Place value here is hundredths. And then the numerator is always the digits we had without a decimal. So my 1 unit could also be considered 100 hundredths. Now the kids have been playing with these blocks long enough that they can pretty much look at them and say, oh yeah, there's 100 little squares in there, right? All right, so let's make this a little bit more interesting. No? You're still coloring? Okay. All right, I'll take my time in making it interesting. I'm gonna grab some pieces. I want you and you and you and you. New page. All right, so next, whoa, I didn't want that to happen. Now, what we're gonna do is we're gonna draw a picture of 1 and 1/10 times 1. And we're gonna envision the area here. So my interpretation is along the edge, these two pieces right here represent my 1 and 1/10, right? Because I'm going 1 this way from here to here is 1, and then I went an additional 10th right here. And then over this way, I went 1 across. So I'm thinking kind of like the number line model there. So I'm setting up a frame. My answer is going to live inside of this frame. And so I'm going to add another piece here. Oops, wrong piece. That one right there. I'm going to stick you down here. Because if I'm thinking about the area model, this is more like the array model, but that's okay. I need that the height of this thing is always going to be, oops, 1 and 1/10 pen. So here I have 1 and a tenth, 1 and a tenth, 1 and a tenth, right? All the way through I have 1 and a tenth. This one down here? Because the height of my figure needs to be always 1 and a tenth tall. So it always has to be 1 and 1/10 tall. So that's what I'm illustrating in my area. Because I need to show a region that is 1 and a tenth tall and 1 wide. So I'm just going to abstract those two out for a second to see that. New page. So if I tighten them up a little, that's about as close as I can get them. Oh, come on, line up. They don't want to line up perfectly. So this is my area that is 1 by 1 and 1/10. Okay, my area key says that one of these big things is 1 hole. So how much area do I have in that picture? How many holes are there? 1. And then I have that green piece. So if the red thing's a hole, what's the green thing? 1/10. So the answer here is 1 and 1/10 for the area. Okay, let's do a slightly more complicated one. Those were just to set up the grid. Yeah, those were just to set up the grid. Because this region right here is 1 that way and 1 and 1/10 that way. So we're going to build another one, a little more complicated. Let's try new page. Let's go 2 and 3/10 times 1 and 2/10. So we have to build a region. We have to decide which is the base and which is the height. Usually I take the first number to be a base, but not always. So I want to go 2.3 this way and 1.2 this way, say. And basically I'm using these other toys as measuring sticks. I'm not really using them as area. So check out, let's see, shift, I want you. So here's my attempt to do it with the toys. So I have to go 1, 2 that way, and then 3 little ones more. So I need to grab a little one, there you are.
We're creating 2 big ones, right?
Ultimately we will, so we're not quite there yet. First we have to measure on each side because it's an area. So I'm using these things as my measuring sticks. So let me build this and I'll show you. So here I went 1 across, 2 across, and now I'm getting my 1. So these are measuring sticks. They're not part of the area. 2 and 3. And I need to tighten this up just a little bit. Let's bring you guys over there maybe. How about there? And you can go there, and you can go there. Okay. So in order to build my rectangle, from some point, I have to measure over 1, 2, and 1, 2, 3/10. So that distance right to there is my 2 and 3/10. And then I got to do the same thing coming down. I got to measure down 1 and 2/10. So that distance right there is my 1 and 2/10. So my area is this region right here. So now our task becomes how much stuff is in there. And this is where I have the kids whip out these toys and try and build that rectangle with your toys. So I know you're drawing it on paper right now. Take a break from the paper for just a sec, and I want to see you with these flats, longs, and skinnies. I want to see you build this region right here. And then we can draw it on paper and just compare our drawing. The drawing is way harder than working with the toys. Don't think about what the answer is. Whatever the final answer is, if you calculated that, ignore that for a minute. Your task is to fill in this rectangle with those toys. Okay, so I'm pulling these guys out of the way. You guys can go down here for a minute, and you guys can go over here for now. So I'm ignoring those guys. I need to fill in this rectangle. So let's see. Usually when I'm filling an area, I try to put the biggest things in I can first. So I'm going for those big red guys, those flats. And I can fit a full one right here. I can fit another full one right here. I don't think I can fit any more big ones, agreed? So now I have to start using the longs. Okay, so I think I can put one right there. Another one right here. And another one. No, you're doing beautifully. Yeah, keep up the good work. And then these guys, I think I can put a couple of those there, right? And that one can go there, and that one can go there. And then the neatest person in the room, I'm going to come take a picture of your work. Neatest person with these blocks, I'm going to come take a picture for Danielle and Libby and the others. Oops. I meant to bring chocolate today. I can't believe I forgot. Okay. How's that? Does yours look similar to mine?
Yes, it does. I'm not done yet, but yes, that's
Okay. Now notice I pulled my pieces away from the top and the left. They're not really part of the area. They were just measuring sticks for me to build my grid. So just a note here on yours, Marina. These guys at the top inside, those are extra. They're not really part of the area. They just are measuring sticks. Okay. Ooh, that looks good. All right, we got an extra here. You've got, this is good, 2.3 that way. This way should only be 1.2. So you have a whole extra row here.
right here.
Yeah, it doesn't belong.
Oh.
Because it was not, you did 2.2, right? 1, 2,
1.2.
yeah, 1.2. Yeah. Ooh, nice array there. That's gorgeous. All right, who's am I going to take a picture of? I'm going to go for yours. Oh, you're helping her out there? Or what? Or were you stealing hers? Oh, did you steal her so she wouldn't get her picture taken? Oh, that's mean. All right.
Yep, that was helping.
Okay, I had a kid like you in my class once in third grade, man. She was trouble. Okay, I got a picture of yours. Thank you. It's only now you're trouble. You were the teacher's pet. I was not the teacher's pet. I was too shy.
You were too shy?
Oh my gosh, I was so shy. It was painful.
Then how'd you meet your wife?
I stalked her until she asked me what I wanted. And I said, "Do you want to go out sometime?" And she turned around and walked away without saying anything.
Really?
Yeah.
I'm brutal.
I know. I was like, but I didn't give up. Yeah, I didn't give up. Eventually, I got a date. She just walked away. Yeah, it's like, oh my God, I smell or something. Okay, so we've got our grid here. So the next thing is to tease the answer out of the grid. So we don't have an answer yet. We just have an area, right? Because we have to count. So let's see, how many holes do we have here? 2 holes given our key from before, okay? So I have 2 holes. How many tenths do we have? 7? 7 tenths. And then I have a 2x3 grid of hundredths there. So it looks like we have 6. Now, sometimes it's a little more complicated because we might have to trade in some tenths for ones or some hundredths for tenths. If either this group gets too big or this combined group gets too big, we might have to trade in. Do you remember doing that back with just whole numbers? Right, we did that back with whole numbers. So same idea. Now our key has changed. This right here is one whole. And so I can see the answer is 2 and 76 hundredths. Okay. So it's just a matter of guiding someone through setting up that area. Or if you leave spaces between them, we call it an array, right? I like the area because it's easier to draw on paper. So let's do one more of these, and then we're going to talk about division and then do some project stuff. So new page. Let's try drawing a picture of 2 and 4 tenths by 1 and 3 should be sufficient. 3 tenths. So we're going to modify it a little bit. 2 and 4 tenths times 1 and 3 tenths. And again, you got to focus hard not to use the slang 2.4 times 1.3. Call them properly. So I want you to either use the toys or draw it or both, your call. I'm going to attempt to draw without the toys. So usually first thing I do is I draw my 2 perpendicular lines and then I start measuring out. So I'm going to steal one of those things for a measurer. Let's grab this guy maybe. It is way easier with the toys, isn't it? That's why I keep saying, like when we're playing with the kids and even when we're playing in class, it's probably more beneficial to use the toys than to draw it. But because you guys are going to be teachers, I need you to be able to draw it too. So here's 1. And if I slide that over, there's 2. And slide you over again, I can get my tenths. Put you right there maybe. And I want how many? 4? 1, 2, 3, 4 tenths. Okay. And I got to come down this way. And I've got to come down, what, 1? And then my tenths. 1, 2, 3 tenths. All right, so I'm just going to stick you there for now. So my area is this region over here to the best of my artistic region. Now, if I'm not using the toys, like if the kids are using the toys in front of me and I don't have them, so let's make believe that guy's gone. Oh, it is gone. Then what I do is I just draw based on my measurements divisions. Like I'm going to take this hole all the way through, that hole mark all the way through, and then these tenths need to be marked through. And this hole needs to go all the way through, and these tenths need to come all the way across. So that right there is my answer as an area grid on paper, if I'm not using the toys. And so now we have to figure out what the heck the answer is. So far I have 1, 2 holes. What do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my gosh. This group and this group make a new hole. So I'm just going to make a note. I can trade 10 tenths for 1 hole. And what do we have here? This is a 3x4 grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can do another trade in here. And that's going to give me a trade of 10 hundredths for 1/10. So counting these up, what do I think I have? I think I have 1, 2, now 3 holes. I've traded in all of my tenths. Nope, I got 1/10 here. I lied.
Did I do it wrong? 1, 2, 3, 4. Wait, I did.
And then I have 2 hundredths. There's another way we can look at this. So, no, you didn't. You get it right.
I did because I only added 3.
Ooh. You should have 4 going this way, which you
Yes.
do. And you have 4 that way, and you have 3 that way. No, you did it right. Yeah.
Then how come you have 4? You did it wrong.
Where?
Oh,
No, I'm okay. Yeah, no, we have the same picture.
Cool. This is fun.
I'm glad you think it's fun.
I enjoyed this more than the last section.
Fractions are hard. Yeah. We're going to review them some more. I'm sorry you hate them. Because here's the thing. You cannot pass your hatred on to the kids. We do not live in a society where we pass on hatred. We are trying not to live in a society that we pass. So we're all going to do our best to not pass on hatred. I think I need to get you a shirt that says "I love fractions," and you can just wear that every day you go to do fractions. Okay. All right. Corey won't wear it. Okay. I will look into that. Somebody just gave me a cool math shirt the other day. You ever hear of I, the imaginary number in math? It's the square root of -1. And it says, I support imaginary numbers, not alternative facts. It's pretty cute. Okay, anyway, so we got an answer out of this, but I just want to take a look at this a slightly different way. Remember expanded multiplication before? No? Okay, so expanded multiplication is where we looked at place value as we were doing it. So check this out. So here's a slightly different way to look at this picture. This group right here, that's 2 holes, right? Okay. But don't you agree that a hole is made up of a whole bunch of hundredths? Okay. So that part right there means I have 200 hundredths. With me? Right here, 200 hundredths. Now consider this region over here. How much is in that new shaded region there? 4/10, right? But couldn't I also view it as hundredths? How many hundredths is in that region? There are 40 hundredths. I like to put the 0 in front. Okay, guess where we're going next? Down here. What do we see there? 1, 2, 3, 4, 5, 6 tenths or 60 hundredths. And then finally, this last region in the corner is 12 hundredths, pretty obviously, which I would write as 12 hundredths. And then we can stack it and add up. Right? So this picture leads to the expanded algorithm we played with before. So there's altogether we have 2 hundredths. As far as the tenths go, there's what, 11, which we get to carry a 1. And then there's 3 holes. So just a slightly different way without actually talking about trading in. But I think we should talk about trading in. I think we should show the trading in. You did it that way too? She did. Oh my gosh, you are awesome. Yeah. Okay. So I lied a few minutes ago. I said we were going to do division now, but I think I just want to jump right into activities, and we'll do division next class. And then, because you got work to do. All right, so I'm going to stop this recording here. Thanks for checking it out, Danielle. I hope you're feeling better. Everybody else too.